Good morning, students. Today we will be doing formula mass. Already we have completed atomic mass and molecular mass. Now there is a new thing you are going to study today, formula mass. So basically formula mass, what is that formula mass? It is similar to that of molecular mass only. It has no difference in calculations between molecular mass. How do we calculate the molecular mass? Same way we calculate the formula mass. Now the question comes, then why do we require this particular thing then? Now I am going to give you the answer for it. Listen very carefully, it is very important. Now let first you tell me that sodium chloride, potassium chloride, potassium nitrate, potassium sulfate, what are these compounds? Are they ionic compounds or covalent compounds? Sir, it is ionic compound. Fine. Yes, it is ionic compound. So ionic compound, does it exist in the form of molecules or it exists in the form of ions? Or how they are formed, ionic compound? They are being formed by the help of ions or they are being formed by the help of molecules? They are being formed by the help of ions. They exist in the form of ions. That means they do not exist in the form of molecules, right? Yes, they do not exist in the form of molecules. So when they do not exist in the form of molecules, then how will you calculate the molecular weight of that particular substance, the molecular mass of that particular substance, when they do not exist as molecules? Suppose if I ask you, you tell me this statement is correct or wrong, that calculate the molecular weight of sodium chloride. If I ask you, is it correct? No, it is not correct. Why it is not correct? What I said you just now, that sodium chloride is an ionic compound. It exists in the form of ions. It does not exist in the form of molecules. Then if it does not exist in the form of molecules, how can I say calculate the molecular weight? Now this thing, whatever I said you just now, it was pointed out first of all by a scientist whose name was Davy. Davy pointed out this particular mistake. He said that it is wrong to say that calculate the molecular mass of an ionic compound when ionic compound does not exist as molecules. It does not exist as molecules. It is wrong to say. Then what we should say then? He only gave us this term that instead of molecular mass, we should use the correct term, that is formula mass. Why we use this particular thing? So as to differentiate between ionic and the covalent compound. When I say formula mass, you are sure that I am talking about ionic compound. But still today we are using molecular mass for ionic compound also. Still today in many of the cases we are using it. But as I said you, it's a new term, it's a new concept. It is used in the modern theory now that we should use the term formula mass for calculating the the mass of an ionic compound. Otherwise there is no difference. For example, you can see it here, I am given you on the screen, you can see ionic compounds such as NaCl, KNO3, Na2CO3, etc. do not consist of molecules but exist as ions. These ions are closely packed together in three-dimensional spaces. 3D means three-dimensional spaces. They form a solid, isn't it? Clear? Hence, in such cases, the formula is used to calculate the formula mass instead of molecular mass. Got it? So, for that particular case, for example, formula mass of sodium chloride is how much? 23. Atomic mass of sodium is, and chlorine 35.5. You add it, you will get 58.5 AMU. U means AMU, that is. Same thing as molecular mass also we do it. Got it? Now got the difference? So formula mass is just a term which is being used to calculate the the weight of ionic compound. It is used to calculate the weight of ionic compound. It is not used to calculate the weight of molecular compound or covalent compound. For covalent or molecular compound we still use molecular mass. Got it? Clear? I think it's clear to you. That's not problem should be there in it. Got it? It's simply a term. We use it correctly. So hence formula mass is sum of the atomic masses of various atoms represented by the formula of an ionic compound. You can say the definition of formula mass is that, I repeat, formula mass is a sum of the atomic masses of various atoms represented by the formula of an ionic compound. Again I repeat, formula mass is a sum of the atomic masses. Here you can see I have added the mass of the atom. Alright, 23 plus 35.5, I've added the mass of the atoms represented by the formula. So what is the formula of ionic compound like NaCl? Sodium chloride is NaCl. So hence I added the atomic mass of Na and Cl and I got the answer, and that particular answer is nothing but your formula mass of ionic compound. Now when I represent this formula mass in terms of gram, now here I have represented in terms of A mu. But when I convert it into gram, that is known as gram formula mass. Just like when I represent the molecular weight in grams, that is called as gram molecular weight. When I represent the atomic weight in grams, that is called as gram atomic weight. Got it? So here also same thing. Clear? I hope it is clear to you what is formula mass. Clear? So make a note of all these things whenever you are listening to this video or the audio which I am sending it. Hold a pen and a copy with you, and whatever I say, please write it down, because that is the way you can make your note, understood? And you will have a complete note. Once the chapter is over, you will see it. Clear? Now the next we will come to is your equivalent mass. Another new term, you do not know about it. Now equivalent mass. Before I go to the definition, let me make you understand what is equivalent mass. Now what do you mean by the term equivalent? Equivalent means equal to. Almost we can say that, equal to. That is called equivalent. For example, if I ask you, you tell me what is the equivalent weight of, what you can say, chlorine. Alright, if I ask you, calculate the equivalent weight of oxygen. If I ask you, calculate the equivalent weight of hydrogen. So what you will do? Before going to the definition, you just understand the concept first. What you will do? Whatever common sense says, what should we do to calculate the equivalent mass? Our common sense says that, for example, for the timing, let me lead the equivalent mass. Just I am asking you a particular question. Suppose you went to the market to buy some potatoes. You want half a kg potato. What the shopkeeper does? He puts half kg in one pan and potato in another pan. Alright, what he does? He puts half kg in one pan and potato in another pan, and he compares it. And he gives you half kg potato. Similarly, if you want 1 kg of sugar, same thing. He will put 1 kg in one pan and sugar in another pan. He will compare it and he will give it to you. Got it? That what he does? Similarly here also, when I say equivalent mass, suppose I asked you equivalent mass of chlorine, what you will do? You will put a standard weight. There half kg, 1 kg was the standard weight, isn't it? And the potato, sugar, whatever it is, that is the unknown weight, which you want to calculate, which you want to compare. So here the same thing. There is some standard equivalent weight is there. You will put the standard equivalent weight in one pan, and the equivalent weight of the substance which you want to calculate, you are going to put it in another one, and you will compare it, and you will get the what you can say weight. That weight is called as the equivalent weight of the substance. It's very simple, isn't it? Again I repeat, if you want to calculate the equivalent weight of chlorine, alright, then what you will do? You will put what you can say a standard equivalent weight in one pan and the unknown weight in the other pan, and you will compare it. The weight which you will get it, that is equivalent weight of chlorine. Simple. Alright, now the question is coming into your mind, what is the standard equivalent weight? Which weight is the standard? There I know half kg, 1 kg, 2 kg, 3 kg, they are the standard weight, whatever the weight I want. Here what is the standard equivalent weight? Yes, now I will come to the definition. Alright, so the equivalent mass of a substance, you see on the screen it is there. The equivalent mass of a substance is defined as the number of parts by mass of that substance which combines with or displaces directly or indirectly 1.008 parts by mass of hydrogen, or 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine. So what does it say? That is the same thing. Equivalent mass is defined as the number of parts. It's a parts. Equivalent mass means what we are doing it is again same thing. We are getting a ratio, understood? So hence it said it's the parts by mass of that substance which combines with, either it combines with or it displaces directly or indirectly. Alright, you have read the displacement reaction in the lower classes, you have read the combination reaction in the lower classes. So either it may undergo combination reaction, or it may undergo displacement reaction, or it may undergo double decomposition reaction, any sort of reaction it may undergo. Got it? With what? 1.008 part by weight of hydrogen, or 8 part by weight of oxygen, or 35.5 part by weight of chlorine. That means you will take either 1.008 gram of hydrogen as a standard weight in one pan, or you will take 8 gram of oxygen as a standard weight in one pan, or you will take 35.5 gram of chlorine as the standard weight in one pan. So here listen carefully, 1.008 gram is considered to be as a standard equivalent weight, or 8 gram of oxygen, or 35.5 gram of chlorine. Now the next question it may come into your mind, that why these three elements only? Because it is considered that these three elements are the most reactive elements and they form most of the compounds with the known metals or the non-metals. Isn't it? These three elements are the most reactive elements: hydrogen, oxygen, chlorine, most reactive elements. You can see with chlorine, it is halogens, it is having high electronegativity. So most of the metals combines with it, as well as the non-metals. Isn't it? Similarly with oxygen, it forms several oxides. Similarly with hydrogen also same thing, it forms several oxides, hydrides and so many. We can say acids, bases and so many it forms. So these three elements are the most reactive elements. They combine with most of the metals and non-metals and the known elements to form several compounds, we can say. So hence these three elements are chosen for the what you can say standard, what you can say equivalent weight. Now the question comes, how we got this value 1.008 or 8 gram or 35.5 gram? How do we got this value? See here, the bottom you can see on the screen. Equivalent mass of an element is what? Atomic mass of the element by valency of the element. Okay, what I said? Atomic mass by valency. Let us come to hydrogen first. What is the atomic mass of hydrogen? It is actually 1.008. I told you when I was teaching hydrogen, what you can say atomic mass. I told you that atomic mass of hydrogen is actually 1.008, but we take it for our convenience as 1. Got it? Because it is less than 0.5, so we take it as 1. Got it? So it is 1.008 atomic mass, and valency of hydrogen is how much? 1. So atomic mass by valency. So equivalent weight, how much you got it? 1.008. Okay, fine. Let us come to oxygen. Oxygen, what is atomic mass? 16. Valency of oxygen is 2. 16 by 2 is how much? 8. Let us come to chlorine. Chlorine atomic mass is 35.5. What is the valency? 1. So how much you got it? 35.5. Now is it clear? What is equivalent weight? We just compare it. In one pan you can put it the standard equivalent weight, in other pan the unknown one, and you can compare it, and whatever you get the answer, that is the equivalent weight of that particular substance. In this way practically we do it, but theoretically how will you do it? That is a formula, just I said you. We will take a standard equivalent weight and we will find it out. So how do we find the equivalent weight of the standard substance? Standard element like hydrogen, oxygen and chlorine, we find it out in this way, atomic mass by valency. But the elements which have got variable valency, their valency depends upon the compound. See here, I have given you a formula. Iron is having variable valency. Iron, copper, tin, nickel, chromium, manganese, many elements are there, especially elements of the D block. D block means transition elements. Got it? So they are having elements of group 3 to 12. They are transition elements. They are said to be as. You have studied in periodic table group 3 to group 12. They are transition elements, or the D block elements are said to be as. They are having basically variable valencies, those elements. So here you can see, if I take ferrous oxide, so how will you find the equivalent weight of iron? 56 by 2. Atomic weight is 56 of iron and valency is 2. Ferrous oxide valency is 2 iron. We got 28. You can see I have written there. Equivalent mass of iron in ferric oxide, it is 56 by 3. So I got it 18.66 or 18.67, we can say that. Valency of Fe is 3, we can say. So in this way, what we find is that for element which is having what you can say variable valency, we calculate the equivalent weight of that particular element by the what you can say atomic weight by valency of the element in that compound. In that compound, if you ask me, sir, what is equivalent to copper? Your question is wrong, because you did not give me the compound of copper. If you would have said, sir, copper oxide means cupric oxide, then I will say yes, 65.5 divided by 2. Got it? So for variable valency I need to say. But if you ask me what is equivalent weight of sodium, no need of what you can say that is compound of sodium, because sodium is having monovalency. It is monovalent in nature. Understood now? Equivalent mass of a particular substance. More of it I will tell you in the next. Thank you.